Hey, this is Math 6, Unit 2, Lesson 1, Introducing Ratios and Ratio Language. Alright, so first of all, we begin with this picture here in today's lesson. And we can see we have lots of different colors and shapes and different sizes there. So what we want to do first of all with this is answer some questions, and so you can kind of pause your screen here and take a look and answer these questions below. But we're going to be looking at different ways that the picture, right, can be sorted by maybe color. We can look at how it can be sorted by area, and then perhaps a third way you can sort these different groups here. So if you're working on this in class today perhaps, or you're doing your own, just take a moment just to pause the video real quick and see how many different ways you could sort these, okay? Okay, so if you're looking at color, we notice that there are several different colors. I could sort this into a yellow group, right? We could sort it into a green group. We could sort it into a blue group, and we could put it into a group of red shapes as well. Right, so that would work there. We could do that, and that would be a way of kind of counting up how many yellow, how many green, how many blue, how many red. Okay, and if that was the case, if I wrote yellow, blue, green, and red, I could actually count those up and say, well, I have 1, 2, 3, 4, 5 yellow. I have 1, 2, 3, 4, 5 blue. I have 1, 2, 3, 4, 5 green, and I have 1, 2, 3, 4, 5, 6 red. Alright, just doesn't make a difference what it is, just happens to be what it is. So that's how I could sort those out, count them up, and make little groups based upon color. I could also do it based upon area. Alright, when I take a look here, I can count up. This one has an area of 1, 2, 3, 4. So I know I have area lengths of measurements of 4 units. Here's one of 1, 2, 3. So I can drop that there and put a 3. That's a 4. This is a 1, 2, 3, 4, 5. Alright, so I have 5. This is a 5. Here's a 2. 1, 2. So I have areas of 2, 3, 4, and 5. So I have 5 different area groups I could put them into, right? I could sort them by color. I could sort them by area. That would work, no problem. What are some other ways you could sort these? That's for you to think about a little bit. In categories, maybe you do it by the shape, maybe by the number of sides they have, number of edges. Those are all ideas you could use there. But the idea is that with a group of shapes and colors like this, there are a variety of ways you could sort them and group them. And with those different sorting and grouping kind of matches up, that leads us into a way of categorizing things. So we have here, it says the teacher's collection. Think of a way to sort your teacher's collection into 2 or 3 categories. 2 or 3 categories. Record your categories in the top row of the table and the amounts in the second row. So what I did real quick is I just drew some pictures here. I didn't find any kind of toys around the house to do there. All my kids' toys are put away up in the attic. So not because they don't play with them, but because they're older now. So no Lego sitting around, things like that. So I drew some pictures here. Okay, I have some blue shapes, some more red shapes, and a couple green shapes here. So are there a couple categories I could do things? Sure. I could do categories of things that are squares. I could do squares, I could do circles, and I can do triangles because I can see that there are multiple shapes there, right? I have circles, squares, and triangles. When I look at how many circles there are, I have 1, 2, 3, 4 circles. For squares, I have 1, 2, 3, 4 squares. And I have 2 triangles right there. So I can take my collection of shapes here and objects, and I can decide what categories I want to use and how many are in each category. As a result, then now I have here a nice little picture that helps me organize my information. Right? 4 squares, 4 circles, and 4 triangles. And so I can do some other things with that, which we'll do here in just a second. So when I look at the next page, it says, have your teacher look at your work there, great, and then write at least 2 sentences that describe ratios in the collection. Remember, there are many ways to write a ratio. So we said, first of all, we had squares, circles, triangles, and we had 4, 4, and 2 from the picture that I gave you guys to look at. So a couple things we could say. We could say the ratio, here's just an example, there are lots of things you can do. The ratio of squares to triangles is 4 to 2. So what I'm comparing there is I'm comparing the squares, the triangles, and the number that there actually were in my grouping. So the ratio of squares to triangles is 4 to 2. Another thing I could say is I could say there are 4 circles for every 2 triangles. Right? Every time I have 4 circles, I have 2 triangles. And that's a true statement there. So there are different ways I can write these ratios out. And there's just a couple samples there. You could think of some other ones there if you like as well. Alright? So I sorted my shapes into squares, circles, and triangles. Are there other ways we could sort these shapes? Okay? If I go back here and look at that shape that I drew for you. There it is. Can I sort this a different way? Because the third activity today is your collection, and they want you to sort your own collection. So if you were just at home or whatever using mine, is there a different way you could sort these shapes besides square, circle, and triangle? Well, we notice some have happy faces, some have sad faces. We also have the 3 colors, right? So just by colors, maybe you wanted to go ahead and you sort them by color, and you group them by blue, and kind of our red color, and our green color, right? Something along those lines. How many blue do you see there? 1, 2, 3, 4, 5. How many red? 1, 2, 3. And how many green? We have 2. Now from that, we can then write 2 more sentences to describe the ratios that we see in that collection, right? We can say things like, the ratio of blue to red is 5 to 3. We could say the ratio of green to blue is 2 to 5. We could say there are 3 red for every 2 green. Something along those lines. So there's different ways you could write that out, and you can sort that, and just to share, the different ways that you're making a ratio there. So go ahead and do that on your own. Write a couple phrases or sentences you could use to describe the 3 categories there. Again, another category you could have chosen is you could have done 2 categories, right? And you could have done happy faces with sad faces. And you could have found a number for those, a number for there. And the idea is that you're just finding that association between 2 or more quantities. You're finding a way that those things are connected in some way. Okay? So let's take a look here at the Are You Ready for More real quick before we get to our lesson summary. It says use 2 colors to shade the rectangle so there are 2 square units of one color for every 1 square unit of another color. Alright, so let's do this here. So we're going to go with, let's shade this one 2 right there. Okay, I'm going to shade this one a 2. I'll shade this one a 2, and a 2, and a 2. And there are different ways of doing this, but this is just one way, right? So there's 2, and for every 2 blue, I'm going to have 1 yellow. So 2 blue, 1 yellow, 2 blue, 1 yellow, 2 blue, 1 yellow, 2 blue, 1 yellow, 2 blue, 1 yellow. Obviously I have some more space there, so I can go ahead and do 2 blue right here, which means I need 1 more yellow, and I need 2 more blue here, which gives me 1 more yellow. Okay, so using colors there, we divide that shape into 2 squares that are blue for every 1 square that is yellow. Alright, so the rectangle you just colored has an area of 24 square units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yep, so 6 times 4 is 24, that's correct. Let's draw a different shape that does not have an area of 24 square units, but that can also be shaded with the 2 colors in the 2 to 1 ratio. Okay, so here is one shape with 2 to 1 ratio with those colors. It wants us to do another one. Now, in order to do that, I have to think about the ratio a little bit, right? Because if I look at just, for example, this space right here, let me just kind of circle that for you. Let's say I just took out and cut out this section right here. If I cut out that section, I have a ratio of 2 blue for 1 yellow, 2 blue for 1 yellow, right? So if I drew that out here, looks something like this. Here's my yellow, and the blues then come down like this. So we're just taking a portion of that big one to make it there. Now, the deal here though is it doesn't have to be an area of 24 square units. This has an area of 2 by 3, an area of 6 square units, but it still has the same ratio. It's still 2 blues for every 1 yellow. You see how that works there? So I have 2 blues, 1 yellow. There are a variety of ways I can do this. I could even just simply have that, and that would work as well, wouldn't it? I could have 2 blues and 1 yellow, and that would still satisfy the criteria what they want us to have here. This would of course have an area of 3 square units, if that was the case there. So there's a couple ways of doing this. Actually, there's lots of ways of doing it. You can draw multiple shapes. The idea is that as you draw that different shape, you just want to make sure you have a ratio of 2 to 1. And that's the ratio you're aiming for, so do that again and again. Okay? So in summary today, we just want to talk and just say that a ratio is an association between 2 or more quantities. And there are many different ways to describe a ratio, the situation in terms of ratio. You could draw it with a picture here that looks like this, a 2 to 1, 2 to 1, 2 to 1, or also look at it saying, well, actually, it's 6 green squares for every 3 circles, right? So it's a 6 to 3 ratio. We could also look at it and say, well, it's also a ratio of circles to squares. There's 3 circles for every 6 squares. Things you can do. We can also notice that you can rearrange those groups and you can kind of circle them like this, right? We could box it like that and say, well, actually, I have some smaller groups here, don't I? I actually have 2 squares for every 1 circle, 2 squares for 1 circle, or 1 circle for every 2 squares. So those associations is what we're talking about when we're dealing with a ratio. And there are many ways to describe what's going on, but you do want to be careful and consistent with the numbers and the words matching up. Notice that 2 squares, the number 2 has to match the squares, and this 1 needs to go with circle, otherwise it wouldn't work out. So do be careful about that, because as you'll see in some of your activities in this unit, sometimes they change the words and numbers around. You just need attendance and precision there to make sure you know what's going on. Alright, so let's pause there and then do your homework, and we'll come back and check that together in a moment. Alright, here we are working on our homework for Math Grade 6, Unit 2, Lesson 1. It says in a fruit basket there are 9 bananas, 4 apples, and 3 plums. So let's just make a little note here. For bananas, we're 9. For apples, we're 4. And for plums, we are 3. That's just my notes, just so I don't have to look back at the problem so often and just see, okay, that's what we're dealing with there. Right? Apples, bananas, and plums. The ratio of bananas to apples. This is where the order is really important here, like we talked about in our summary. Bananas to apples. Bananas is 9, and apples is 4. So make sure you get that order right. If you have the order wrong, it's going to be the wrong ratio. The ratio of plums to apples. Plums was 3, apples is 4. Notice you can write it with the colon, or you can write it with the word 2. Both are just fine. For every blank apples, there are blank plums. Okay, well, apples is here, so for every 4 apples, there are 3 plums. D. For every 3 bananas, there is 1, Well, first of all, this is a great question, because why? Well, it says 3. I notice that here bananas, it doesn't have 3, does it? I have 9. So what's that telling me? It's telling me that something is changing in that ratio a little bit. Think back to when we looked at the Are You Ready for More with the square and the area of that rectangle. When we looked at the area of that rectangle, what happened was we made it a little bit smaller, but the ratio stayed the same, right? Here there were like 24. In this case here, there's a ton of blue, aren't there? right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 blue compared to 1, 2, 3, 4, 5, 6, 7, 8 of the yellow. Now that 16 blue, 8 yellow, that's the ratio, but it's the same ratio over here. Here there's 4 blue, right, and 2 yellow. So the ratio numbers are different, but the ratio itself are the same because it's the same pattern that we're doing there. So there's a way to actually think about it getting smaller, which was in the summary part of, well, instead of thinking of that as 6 to 3, can we group them into smaller chunks? So let's look up here. Here we have 9 bananas and 4 apples and 3 plums. So think about bananas. Let's do 9 bananas. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 bananas, right? For apples, we have 4 apples. All right, so we have apple, and we have an apple, and an apple, and an apple. And plums, we have plum, plum, and plum. Okay? So, with the bananas and the plums, I can quickly see an easy relationship between those guys there, right? For every 3 bananas, what do I have? I have 1 plum. That's pretty easy. Now the apples get a little more complicated, so we're not going to look at those today, but the apples can be figured out, but it's a little more complicated, isn't it, right? I don't just have 1 apple for each one, because I have this extra apple. It doesn't quite work out. So apples will be a different day, different lesson, but for now, we can look and see, well, the plums seem to go well with the bananas in an even ratio there. Okay? So there's 3 to 1 when it comes to bananas and plums. Number 2. Complete the sentence to describe this picture. The ratio of dogs to cats, all right, is what? Well, dogs. Dogs, I see 1, 2, 3. And cats, I see 1, 2, 3, 4. So dogs to cats is 3 to 4. And I could write 3:4, or I could say 3 to 4. Both are acceptable. For every blank dogs, there are blank cats. Well, for every 3 dogs, there are 4 cats. Right? And that's all we got to do. Number 3, write 2 different sentences that use ratios to describe the number of eyes and legs in this picture. All right. So, besides the eyes, we can see here there are 2 eyes on that hippo and 2 eyes on the turtle. We can say they each have 4 legs, 4 legs, 4 legs. So we could say some sentences like, and these are just examples, for every 4 eyes, there are 8 legs. And that's a true statement. Here are 1, 2, 3, 4 eyes, and there are 8 legs. I could do it the other way. I could say for every 8 legs, there are 4 eyes. That would work. I could also reduce it down, right? I could say for every 4 legs, there are 2 eyes, right? Here are 4 legs, and it connects to the 2 eyes. 4 legs, 2 eyes. So you come up with your own idea there as well, but those are a couple examples. All right, number 4 is review from our last unit. Choose an appropriate unit of measurement for each quantity. So we have centimeters by itself, which we would use for measuring something, a length. We have something cubed, which is what we use for volume. And we have something squared, which we would use for area. So, area of a rectangle, I think we would go with centimeters squared. That's an area thing. Volume of a prism, centimeters cubed. The side of a square, that's a length, so just centimeters. Area of a square, back to centimeters squared for area. And volume of a cube, centimeters cubed, right there like that one. All right, let's turn the page and look at our next one. So that is find the volume and surface area of each prism. All right, let's slide over so you can see it all. All right, prism A, we want the volume and surface area. So we have a height of 3, a length of 3, a width of 3. So for our volume would be 3 centimeters times 3 centimeters times 3 centimeters, which totals up to 3 times 3 is 9, times 3 is 27, so 27 centimeters cubed. For surface area, we have to get the area of one face, and one face here is going to be a 3 by 3 face, right? So the area is going to be 3 centimeters times 3 centimeters, and then we're going to need to multiply that by the number of faces. It's a cube, so a cube is how many faces? 6. So 3 times 3 is 9, right? And then 9 times 6 is 54. We have centimeters, but there are only 2 of them, so 1, 2 becomes centimeters squared. So 54 centimeters squared. For the next prism, we have the volume would be the length, which is 5, the width is 5, and the height of 1. So 5 centimeters times 5 centimeters times 1 centimeter, which equals 5 times 5 times 1 is 25 centimeters cubed. Now the surface area here will be a little bit different, right? We have an area here of this side, it's not a cube this time, we have a side right there, that face is a 5 by 1, right? So it's 5 times 1 is that shape right there, but there's 1, 2, 3, 4 of those. Multiply that by 4. Then the top we have 5 by 5. The top and the bottom, and there are 2 of those. So a lot more numbers here, right? So 5 times 1 is 5, times 4 is 20. So we know we have a 20 right here for this part. And 5 times 5 is 25, times 2 is 50. So then we're down to 20 times, not times, plus, I'm so sorry. I can add those up. So 20 plus 50, because I have the sides there plus the ones there, so 50 plus 20 is going to be 70 centimeters squared. Sorry about putting that multiplication, should be addition, right? We're just adding those up. So we get 70 centimeters squared. Compare the volumes of the prisms and then their surface areas. Does the prism with the greater volume also have the greater surface area? Well, the greatest volume is here, A, and the greatest surface area is B. So that's not the case. Having a greater volume does not always mean you'll have a greater surface area. Okay? It just doesn't work that way. There are 2 different types of measurements. And finally, number 6, which figure is a, hey, surprise, surprise, triangular prism? It's back, our famous triangular prism. So we want to find a shape that has triangles, right? And is a prism, which means that it has a base and a top and a bottom that are triangles. So it should have 2 of those, and then it should be enclosed by a bunch of squares, rectangle shapes like that. So A, we see a triangle, enclosed by a bunch of rectangle square shapes. A is going to work. B, I see no triangles. That's a pentagon, not going to work. C, we got a triangle top and a triangle bottom, and surrounded by a bunch of squares and rectangles. Great. D, we have a triangle and a triangle surrounded by a bunch of rectangles and shapes. And then finally over here, we do have a triangle, but we don't have a triangle top and bottom. This one is a pyramid, not gonna work for us. So we're gonna go with A, C, and D, and that is it for today. And that's all. Have a great one. We'll see you next time.